Welcome students. Today we are discuss the unit number 6, Introduction to Advanced Microprocessor, and we discuss the topic 8086 architecture. Student will be learn the following objective from this lecture. Features of 8086 microprocessor, comparison between 8085 and 8086 microprocessor, architecture of 8086, pipelining concept of 8086 microprocessor, and maximum and minimum mode of 8086 microprocessor. 8086 microprocessor is an enhanced version of the 8085 microprocessor that was designed by the Intel in 1976. It is a 16-bit microprocessor having the 20-bit address line and 16-bit data lines provide up to the 1 MB storage. It consists of powerful instruction set which provide the operation like multiplication as well as division easily. It supports two mode operation, maximum mode and minimum mode. Maximum mode is suitable for system is having the multiple processor and minimum mode is suitable for having the single processor. Features of 8086. Most prominent features of 8086 microprocessor as follow. It has instruction queue which is capable to storing the 6 instruction byte from the memory and resulting in faster processing. It was first 16-bit microprocessor having the 16-bit ALU, 16-bit register, internal data bus, 16-bit external data bus resulting the faster processing. It available in 3 versions based on the frequency operation, 8086 with 5 MHz, 8086 8 MHz, and 8086 at 10 MHz. It used two-stage pipelining, fetch, execute, and which improve the performance. Fetch stage can be prefetch up to the 6th byte of the instruction and to store them in the queue. And execute stage execute these instructions, and it has 256 vector interrupts and it consists 29,000 transistors. Comparison between 8085 and 8086 microprocessor. So we are make the comparison based on size. 8085 is 8-bit microprocessor, whereas the 8086 is a 16-bit microprocessor. Address bus. The address bus size in 8085 is 16-bit address bus, but in case of the 8086 is a 20-bit address bus. Memory supported by 8085 up to the 64 kilobyte, 2:16, and whereas in 8086 it access up to the 1 MB memory, 2:20 is equal to 1 MB. Instruction set. So 8085 does not have the instruction queue, whereas the 8086 has instruction queue. Pipelining. 8085 does not support the pipelining concept or architecture, while the 8086 support the pipelining architecture. Input-output pins. So 8085 can access 2:8 means 256 IO, whereas the 8086 can access 2:16 means 65,536 IOs are there. The cost of the 8085 is low as compared to 8086. Now architecture of 8086. So architecture of the 8086 are mainly divided in two portions, BIU and EU. So BIU is a bus interface unit and it is consists the segment registers, prefetch queue, control systems, and system bus. And execution unit is consists our general purpose registers as well as arithmetical unit, ALU, and flag registers. 8086 microprocessor is divided into the two main functional units, EU execution unit and BIU is bus interface unit. Now we are discuss about the EU. So EU means execution unit. Execution unit is give the instruction to the BIU starting from where is to fetch the data and then decode and execute those instructions. Its function is to control operation on the data using the instruction decoder and ALU. EU has no direct connection with the system bus as shown in the above figure. So it performs the operation over the data through the BIU. Let us now discuss the functional part of the 8086 microprocessor. So ALU So ALU is perform all the arithmetical and logical functions like addition, subtraction, division, multiplication, as well as logical operation like or, and, not. Flag registers. So it is a 16-bit register that behave like a flip-flop. It changes the status according to the result stored into the accumulator. It has 9 flags. They are divided into the two groups. Okay, the conditional flag and control flag. So this is the format of the flag register. The size of the flag register is 16-bit, but it is consist at a time 9 flag is there. So among them, the 5 flag are conditional flag, and the remaining 4 are control flag. It is a 16-bit register that behave like flip-flop. It changes the status according to the result stored into the accumulator. It has 9 flag. They are divided in two groups, conditional flag and control flag. Conditional flag, it represents the result of the last arithmetical or logical instruction executed. Following is the list of that conditional flag. Carry flag, this flag is indicates the overflow condition or arithmetical operations. Auxiliary flag, when the operation is performed at the ALU is result in a carry or borrow from the lower nibble that is D0 to D3 and to upper nibble that is D4 to D7, then this flag is set. Carry is given by the D3 to D4 and auxiliary carry flag is set, and this processor use this flag to perform the binary to BCD conversion. Parity flag, this flag is used to indicate the parity of the result. When the lower order 8-bit of the result contain the even number of ones, then the parity flag is set, and for odd number of ones the parity flag is reset. Zero flag, this flag is set when the result of the arithmetical and logical operation is 0, else it is set to 0. Sign flag, this flag is hold the sign of the result, that is when the result of the operation is negative, then the sign flag is set to 1, else set to 0. Overflow flag, this flag is represent the result when the system capacity is exceed. Control flag, control flag is control the operation of the execution unit. Following is the list of the control flag. Trap flag, it is used for the single step control and allow to user to the execute one instruction at a time for debugging. If it is set, then the program can be run in a single step mode. Interrupt flag, so it is an interrupt enable and disable flag. It is used allow the enable and disable the interrupt. It's set to the 1 for interrupt enable condition and set to 0 for disable the interrupt. Directional flag, it is used in a string operation. As the name suggests, when it is set string byte or exit from the higher memory address to the lower memory address and vice versa. General purpose registers, there are 8 general purpose registers are there: AH, AL, BH, BL, CH, CL, DH and DL. This register can be used individually to store the 8-bit data and can be used in a pair to store the 16-bit data. The valid register pair AH, AL, BH, BL, CH, CL, DH, DL is referred as AX, BX, CX and DX respectively. AX register, so it is also known as the accumulator register, and it is used to store the operand for the arithmetical operations. BX register, it is used as a base register. It is used to store the starting base address of the memory area within the data segment. CX, it is referred as a counter and it is used to loop instruction to store the loop counter. DX register, this register is used to hold the input output port address for the IO instructions. Stack pointer, it is a 16-bit register which holds the address from the start of the segment to the memory location, whereas a most recent store on a stack. BIU unit, bus interface unit. BIU takes the care of all the data address transfer on the buses from the EU, like sending the address, fetching the instruction from the memory, reading the data from the ports and memory, as well as writing the data to the ports and memory. EU has no direction connection with the system bus. So this possible with the BIU. EU and BIU are connected with the internal bus. Instruction queue. So BIU is consists the instruction queue. BIU is get up to the 6th byte of the next instruction and store them into the instruction queue. Whenever execution unit instruction and it's ready for its next instruction, then the simply read the instruction from the instruction queue and resulting in increase the execution speed. Fetching the next instruction while the current instruction executing is called the pipelining. The segment register. So BIU has the 4 segment register: CS, DS, SS, and ES. It holds the address of the instructions data in a memory, which are used by the processor to access the memory location, and it is also consists one pointer register IP, which holds the address of the next instruction to be executed by the execution unit. CS. It stands for the code segment, and it is used for the addressing a memory location in the code segment of the memory where the executable program is stored. DS. It stands for the data segment. It is consist of the data used by the program and is accessed in the data segment by an offset address or the content of other register that hold the offset address. SS. It stands for the stack segment. It handles the memory to store the data and address during the execution. ES. It stands for the extra segment. ES is additional data segment which used by the string to hold the extra destination data. Instruction pointer. It is a 16-bit register used to hold the address of the next instruction to be executed. 8086 microprocessor are support the 2 operating mode, minimum mode and maximum mode. So now we have made the comparison between them. It is a uniprocessor mode. 8086 is the only processor in the circuit. Now maximum mode, it is a is a multiprocessor mode along with the 8086. There can be other processor like 8087, 8089 in the circuit. Here MNX bar pin is connected to the VCC to operate in minimum mode. Here MNX bar is connected to the ground for the max mode. ALE for the latch is given by the 8086 itself. As there are multiple processor, ALE for the latch is given by the 8288 bus controller. DN bar and DTR bar for the trans receiver are given by the 8086 itself. As there are multiple processor, DN and DTR bar for the trans receiver is given by the 8288 bus controller. Direct control signal like MIO bar, read bar, write bar are produced by the 8086 itself. Instead of the control signal, all the processor produce the signals S2, S1 and S0 bar. The control signals MIO bar, read bar and write bar are decoded by the 3 to 8 decoder IC 74138. The status signal S2 bar, S1, S0 are required to special decoding are decoded by the 8288 bus controller. INTA bar for the interrupt acknowledgement is produced by the 8086. INTA bar for the interrupt acknowledgement is produced by the 8288 bus controller. Bus requests are grant handled using the hold and HLDA signals. Bus request grant handled using the RQ and GT request and grant signals. Since 74138 does not independently generate any signals, it does not need to a clock. Since 8288 independently generate the clock signals, it need a clock from the 8284 clock generator. Pipelining concept in 8086. Now we have discussed there is no any pipelining concept is available in 8085. So whenever our instruction is fetched from the memory, so it is fetch, execute, then second instruction is fetch and second instruction execute. So whole operation are in a sequence. But in case of the 8086, our first instruction is fetch. When our first instruction is execute, that time the second instruction is fetch from the memory. So our first instruction is execute and our second one is fetch. So these two operation are done simultaneously. Second one is when our second instruction is execute, that time our third instruction is fetch. So in this time, our second instruction is execute, but our third instruction is fetch from the memory. So in this time duration, our two instruction are execute parallelly. So this concept is called the pipelining concept. The concept of the pipelining was introduced by the Intel with the 8086 microprocessor. Due to this concept, the execution of the program become faster. The pipelining is nothing but the queue of the 6 instruction prefetch from the memory. The first instruction of the queue, when the queue is going to be executed unit as a ALU, then the queue is moved forward and the one new instruction come forward from the memory, so that the queue is always filled from the six instructions. The ALU does not has to wait for the instruction come from the memory. This instruction is already prefetched and made available for ALU. So ALU is not go for the wait mode. As shown in figure, when our first instruction is fetch, from the memory, then our in a second cycle, when our first instruction is decode, that time our second instruction is fetch, and during the cycle 3, our first instruction is execute, and our second one is decode, and our third one is fetch. Third instruction is fetch. So in this duration, you can observe that our all the three instruction operation are going parallel, and execute parallel, or all the three operation are as shown in figure. When our all the as shown in figure, our 4 instructions are execute in a 6 cycle. So in a cycle 1, when our first instruction is fetch, and during the cycle 2, our first instruction is decode. That time our second instruction is fetch from the memory, and during the cycle 3, our first instruction is execute, second instruction is decode, and the third one is fetch. That's during the cycle 4, our second instruction is execute, third one is decode, and fourth one is fetch. So you can observe in a cycle 3 and cycle 4 duration, our all the three instruction 1, 2, and 3 are simultaneously parallel execute. So this concept is called the pipelining concept, and this pipelining concept is nothing but the reduce our execution time, and our processor is become faster. Thank you.